Okay, so I have the enviable task of having the last session of the day, and we did start the day with current state of HBase, and so now we're going to finish the day with a potential set of futures for HBase. This is a panel. I just put my own name on there because I'm stupid. It's a panel. So I would like to open this all with a question. Like, so who's driving all of this? Who's driving HBase, right? It's like, and the answer is very easy. It's us from the start, and us is all of you guys in the room. It's the people on the mailing list, the committers, the PMC members, and all of us. We are driving HBase. We are actually defining HBase's future, and nobody else is going to do it for us, right? And if you look around in the ecosystem, you find Kafka has Confluent, Spark has Databricks, Cassandra has Data Stacks, and HBase has, well, what does HBase have, right? That's actually an interesting question, right? So there's vendors that that sell you support and stuff, but they do a bunch of other stuff too, and so they won't drive the HBase vision. It's also true that there are many other groups that either use HBase or fund HBase and are very vocal about it, or fund PMC members or committers. So it's a big community, but it comes back to it's this group that needs to drive the vision and the direction of HBase forward, and it's a big task. It's in a sense a heroic struggle, right? Like this guy here. We have to do it. Nobody's going to do it for us, right? And so then the question is, what is the next thing? What are the areas we should cover, talk about for the future? And one thing that comes up over and over again is cloud. Should we do cloud stuff? Should we do better on the cloud? Or what does it mean, cloud on HBase, HBase on cloud? So the first panelist I have here is Carter Page, who runs the big table team at Google, and he's going to tell us about his thoughts. And you have your own mic.
All right. Hello.
And you can click.
Oh, cool. Hi, everybody. I just want to take 2 seconds just to mention what I mention every time I'm here, which is this is like my favorite conference every year. It's not exactly the biggest conference I go to, but in terms of the actual technical depth and how interesting each of the different events, presentations I go to, it's really unparalleled, and I really love the community that's here. So anyways, I know many of you feel the same way. So we'll talk about cloud, and I'll start with myself. I'm the lead manager for Bigtable at Google. So that's both internal Bigtable. We have an internal Bigtable service or cloud that all of our internal products run on, and then we also have Cloud Bigtable, which I also manage. So I was given the question, what does cloud mean for HBase's future? And I run Cloud Bigtable. So if you really want to get into like what are the details for what HBase should work on, the thing I was thinking about was the Facebook presentation this morning about self-healing systems. So, and go watch that. He talked about it a lot better than I will here. So I'll talk about something else. So you look at cloud, and what's this mean for us? Is this going to mean for the HBase community, is it going to be more problems, more work to do? We're going to stress about, oh no, cloud's coming along and it's going to break our entire world apart. Or is it going to mean free stuff? Well, no, not free stuff, but maybe free engineering. And to explain, I'll back off a second and talk a little bit about where we come from with HBase on Google Cloud. So you can run HBase either in a traditional VM environment using things like Dataproc, or we have like some utilities, things like that. Or you can actually run HBase on Cloud Bigtable. We use the HBase client. You can talk to either one. You can compile code against HBase and run it against Bigtable, essentially. One is kind of a spin up, like I said, run VMs, and you manage it. The other one's kind of a zero ops operation, and our S3s will run a Bigtable cluster for you. So a lot of people ask me, why did HBase end up being the client for Cloud Bigtable? And there's 3 basic answers to it. The first one is because the old way standards were done is kind of gone. With the JCP and stuff like that, it was, despite other reasons with who owns Java right now, it's just too slow. I mean, the reality is when new needs come along, you need people who are committed to the code base, who are actually putting things in that matter, rather than committees of people from important companies getting together and discussing it in a committee for a year and a half and eventually rolling out standards that, by the time they're available, they're great for something that was useful 3 years ago. So open source has really, kind of replaced that, I think across the industry, and I think HBase has done a really good job of being open and being, a community that really pays attention to what the actual needs are. And I think Stack and Andrew and Ines and others and Lars have should take a lot of credit for that. Second thing, which is that HBase is really close, very similar to the way Bigtable is architected. It's about 90% similar in terms of the basic underlying architecture, and so it wasn't a surprise at all to us that the API for the client for HBase fits very cleanly with Bigtable. And the third reason is because we want to support an ecosystem. We don't want to just throw something out there. I mean, one of the things I often say internally is, Bigtable is essentially useless on its own, and because you need these tools, you need your Hadoops, for us, also you can use Dataflow and things like that. You need these things to be able to take full advantage of it. OpenTSDB, for instance, and it's important to be able to nourish this ecosystem. Both because it's the right thing to do. Open source is so important for the technology world right now, as I mentioned before. And it's also, if I'm being purely selfish from a business standpoint, it's a good thing to do business-wise too, because it means you're part of a richer ecosystem. And so, what I mean by supporting, and this gets back to, the free engineering I was talking about, is we'd like to have rich abstractions. We'd like to help support rich abstractions on top of HBase, and we would like to actually invest real engineering time from Google going out and writing and enriching existing or potentially new open source solutions. We want a great graph database on top of HBase that gets the scale of that, but you get the functionality, of a graph database. Maybe we go and look at what Titan could be at another level or something like that. IoT solutions, geo solutions. The presentations I've seen around transactions and SQL and things like that. And so these are all things that we want to help on, and we want to put like real Google engineering time on. So if you have a really good idea, please reach out to me. My email address is up there, carterp@Google. Not kidding, please do email me, and I would like to prioritize a handful of things so we can give back a little bit more to the open source community. Thanks.
Thank you, Carter. Thank you. All right, then we have more views here on this. Our next panelist here is Maxim Lukianov, and so let's take us through your view.
Thank you. It's a pleasure to be here. Future of HBase is a great topic. So I'll start with myself. Oh, I'm already here, sorry. Where is the back button? Okay. So I'm a program manager in Microsoft Big Data team. I'm working on HBase and Spark in Azure Cloud. So there are a few ways to kind of discuss and think about the future. And one of the ways that I like is to try to focus on some fundamental aspect of the system that we are discussing and kind of understand how it works, and then try to project into the future this understanding to spot some opportunities. So one of these fundamental kind of parameters is CPU utilization. So we'll start this kind of exercise with CPU utilization. And at Microsoft, we have a few actually several NoSQL stores. We have several public offerings. HBase is a managed service that we offer in the cloud, and we use Hortonworks distribution, so big thanks goes to Hortonworks and Tennis for all of the support that they provided for us. We also have several internal systems, And when we look across these NoSQL stores, we see a pattern where if you run a poor kind of key value workload on your system, then you see that the CPU utilization usually is very low. And with HBase, we usually don't look at CPU. We have kind of more important things to worry about, like, hey, what's the latency of the system? What's the throughput? How I can improve the throughput? But when the scale kind of grows, it's becoming harder and harder to ignore this problem. On this picture, it's actually an example of from one of the environments of our internal key value NoSQL system that powers some of the functionality of the Bing search. And when you stare at these kind of thousands of machines that don't use CPU at all, you kind of start thinking, hey, how we can do better than that? How we can solve this? And the first obvious kind of solution is, hey, let's go and run some other workload on these systems. And from that point of view, suddenly running analytics on HBase as an idea sounds like a very promising direction. But what if I don't have analytics to run? What if my application doesn't need to run analytics? So the intuition would be, hey, if you can run something on something that is not utilized, then that would lead to some good economic result. But if you don't need to run something, then there is no gain. So the question is, can you do some magic in the cloud? And if you were to talk about some regular or like other NoSQL stores, most of them that I know, actually, this question would be hard to answer. It would be very hard to build something that kind of is able to give back CPUs, because all of the systems are usually kind of tightly coupled with the underlying storage. But fortunately, it's not the case with HBase. With HBase and Bigtable was designed with explicit abstraction of file system. And sometimes it hurts us in HBase, but in this case, it's actually a blessing. This is where HBase shines. It means that you can basically treat file system as a replaceable thing. You can plug other file systems. And we can even think about it as a gene. Like HBase has a specific, special, nicely separated gene, which we can replace, mutate, and we can even think about creating kind of a generation of little HBases that have different file systems attached to them, and sending them into the cloud environment and trying to determine which one kind of survives better. So we did create one of those mutants. And in Azure Cloud, we connected HBase to a remote storage. So let's see if this mutant has any superpowers. There are actually a couple. The first one is what we get in this configuration is we basically get infinite storage attached to a HBase cluster. And that allows us to leverage all of the investments that we did in Azure to kind of bring the cost of the storage down and make sure that it's actually reliable. And the second advantage of that approach is that now we get ability to be very flexible with the nodes of the cluster as well. Now that all of the data is safely in the cloud storage, we can shrink basically this cluster size to exactly the size of the clusters that we need from like throughput requirements of our workload, or from the CPU requirements. And that actually translates, in some cases, in a fairly dramatic economic kind of advantages. If you take a workload that has low throughput requirements but needs a lot of storage, then we calculate it, and we have actually customers that benefit from these patterns that kind of confirm that use case. You can get benefit of up to a 6 times lower cost of your cluster compared to just using regular storage. So you just, oh yeah, that's correct. So now we can go back to the original question. Hey, what is the future of HBase in the cloud? Well, future looks bright to me. As in the cloud, traditionally we get kind of a benefits of the scale or economics of scale. With HBase, we get even more. There is a multiple factor on that. You have a new ways of how you can improve efficiency of HBase in the cloud by improving the CPU efficiency and throughput efficiency of your system. Okay, that's what I got.
Thank you, Maxime. All right, so now we heard about the cloud and potential ways to look at the future there. But what's else? What else is there, right? Is it OLAP? Is it OLTP? Should we write a database? Is it transactions? And there's this, this wonderful quote here, from Jeff Dean when he was asked what his biggest mistake as an engineer was. He said, well, I should have put transactions into a big table. And I think you had a comment to that. You want to have a
Yeah, all right.
seriously.
Thanks for putting me on the spot here. Yeah, so I was watching this video coincidentally two weeks ago, and I saw him say this. He was kind of asked on the spot of like, "What's your biggest mistake as an engineer?" And he said, "Off the top of his head." I want to add a quick context. It made me wince a little bit because there is a much bigger context to this, which is that when Bigtable was our hammer to all nails at Google, basically everyone who needed transactions ended up building their own layer on top of it, and so you had dozens of teams building transactional layers on top of Bigtable and usually doing it very poorly. And this eventually led to us developing Spanner internally. And internally, actually, it's interesting. We thought about, would Spanner one day end up replacing Bigtable? But what happened is we developed two very different workflows. One is you have got Spanner, which is these application databases that need OLTP and strong consistency in transactions. And Bigtable is really specialized on these great big analytical workloads. So it's not that Bigtable needs transactions, but you kind of need two different things.
Thank you. That's a good insight. All right. So then, what is the story for HBase? Knowing that and that comment, and for OLAP, OLTP, transactions, and so on. And so we have the founder and CTO of Splice Machine here, who's going to tell us about his vision. Take that mic over there.
Thank you.
You can take if you like, or I can click. Either way. I will click.
I don't think I know how to click. First of all, I'm really excited to announce that we're making a call for founders for Splice Machine, because we'll be entering the open source community, which is really exciting for everybody in our team. We've been wanting to do that for about 3.5 years, and we wanted to get to a place where we thought we had something that the community would really embrace. So that's very exciting for us. Go ahead. So I have a pretty specific perspective of my view of HBase. I view HBase is, if you look at on the spectrum of compute infrastructure, it's not high-end, really fast OLTP, nor is it all the way on the other end specialized analytics. It's in that middle place, which is what I call multi-tenant kind of mixed workloads, to be able to do some OLTP type processing, and we see, unfortunately, a lot of people trying to do also analytical processing on HBase. So kind of here's my view of the current storage challenges of HBase. First, from my perspective, it does lack transactions. So whether you're an OLTP type system or an analytical system, you need a clear demarcation of, did it succeed or did it fail? And a clear way to roll back that data if that happens. Also, the ordering of data has been a challenge for HBase, whether it's replication or other things. They all get back to the core structure of transactions or guaranteed ordering. We've also started with a single write optimized store. So everybody knows we run an LSM tree, and we're really effective for doing really quick lookups. And we have pretty limited metadata facilities. We basically have what I would consider, we have a Bloom filter, and that's how we give information about data in HBase. As far as execution, so we've heard talks all day, and they've been great. Generally, what you see is for OLTP, which I think we would all agree right now is probably our strength, real quick gets, point scans. On the OLAP, it gets a little foggy in my mind. And why does it get foggy? Well, we started out, if you remember, way back with Hive connector, and we would do things like remote scans, which were relatively slow. And then now we've kind of evolved to where we use co-processors, and a lot of people do internal scans on those co-processors. But we've kind of gone down a kind of slippery slope, right? Because now we're starting to kind of roll our own data engines and other things, which is interesting. And then as a community, even today, we're still talking about compactions. Either turning them off, not using them, and I at least like to hear us talk about it. But it used to be people would not even talk about compactions at an HBase, like it just didn't happen. And I say, do not talk about Fight Club. So when we talk to people about HBase, they're always concerned about that. Good. So at Splice Machine, we've kind of come up with some ideas and designs about kind of a future state of HBase. And we've called it Janus. So really about a duality. And our perspective is a lot of people are trying to do typed type systems, whether they're running SQL on top of it or whatever they're doing. They want to be able to use JSON as a first-class citizen. But the key thing for me is to start to have that typed infrastructure stored in HBase in an extremely efficient serialization format, in our case, unsafe row. We believe HBase should have hierarchical and partition-aware transactions. Why is this? We really believe that a data center or data store of the future has to go across data centers. And it needs to understand this transaction initiated in this data center and when to complete it in another one. And this is something that's very different. We've always focused on a write optimized store, but I believe that should be optional. I think you should also be able to do a read optimized store. This is similar to what an SAP HANA or Oracle Exadata does when you have a fractured store. I think this is absolutely critical because it would allow us to support transactional workloads and be adequate for analytical workloads. With a caveat, we would not be an analytical processing engine. We would be something that would provide columnar storage to analytical processing engines. And lastly, thanks to Yahoo, they've open sourced kind of their full metadata facilities. I think we should build that into a storage engine for HBase where we have cardinality for database engines, theta sketches if you want to do approximations, and frequent items that you can also feed to database engines. Next. And when you look at execution approach, I think we should adopt a dual engine type architecture. Specifically, for all execution engines, whether it's Impala, Hive, I'm going to miss an execution engine, there's Presto, whatever, we should be able to provide statistical hooks to our sketching algorithms. We should be able to provide them, if they say they're going to scan a table, HBase in our core storage should be able to tell them how many rows will be returned, what the cardinality of those rows are, and provide those facilities. I think we should focus on becoming easier for OLAP execution engines. What does that mean? Our input-output formats, those types of things, become higher performant. For analytical engines, they're columnar, but still maintaining a consistent environment. I think we should think heavily about supporting Arrow in that regard. That's the ability to do columnar a single representation of an in-memory execution architecture. And lastly, on the OLAP side, I think we should perform compactions on the OLAP engine. We do that at Splice Machine on Spark. It works. Take compactions out of HBase. They're not meant to be there. They're an analytical process. It's a big bulk workload. Put it in something with a resource manager. And on the OLTP side, let's build on where we're at. I think we're really competent at doing row-based storage and quick remote HBase scans. So that's kind of my perspective, and I know it's really about pretty detailed how we think the system should be implemented, but that's my perspective on how HBase should move forward.
Thank you, John. Just leave it on, it's okay. Would you then say, your main message is we should have the dual engine thing for OLAP, the outsourced in quotes to Spark, and the OLTP we run in HBase, and it's handled by a layer on top, or?
I think really what we should do is say, look, we're not going to get into the resource management business for analytics execution. That's extremely difficult. That's
Yes,
resource
I agree.
pools,
I agree.
that's dynamic container allocation. We should say no, but boy, if you're running an analytical engine, you should want to use HBase. We should be the mutable store for Spark. We should, anything that runs Calcite
I
should
see.
want to use us.
Cool, thank you. So then, it's hard to talk about the future and not talk about the current hardware, right? So HBase is almost 10 years old, right? 10 years ago, how much RAM did the typical box have? 4 gigs maybe, 8 gigs? I'm not sure, but it might have as well run on one of those, right? It's a while ago now, right? So we spent a few minutes talk about modern hardware, data center design, even if we get to that. And so we have Matt Mullins here from Facebook, who's if you could say just for a few minutes what you do at Facebook.
So I'm a production engineer at Facebook. I work on a lot of performance testing, making sure that what we're building is appropriate for our customers, and that's pretty much my main focus right now. And why I'm really in tune with the hardware changes coming on is that I want to make sure that is appropriate to do. We're not, doing unnecessary work for nothing, and make sure that that's going in the right direction.
Do you design your own hardware at Facebook, or do you buy it from vendors and have them design it?
Facebook has the Open Compute platform that is designed in Confluent with a bunch of other companies out there. And so we work with internal teams at Facebook to build out what that spec is. Obviously, the HBase team doesn't directly do that, but that is done at Facebook.
Can you share the rough SKU you're using, or is that secret?
I don't have that information for you right now.
How about your networking? Is it all a fat tree? Is it higher location independent?
Off the top of my head, I don't have the topology on it. I know it is. It's good enough. I mostly don't think about that.
That sounds like you have a fat tree. You don't have to worry about it. Yeah. Is there anything else you want to? What do you take into account first when you design your hardware for things like HBase and
So as Elliot said earlier, the current behavior when machines get overloaded is not good. So building out, making sure that the IOPS capabilities of the system will support the customer, making sure that the caching is appropriate, sizing, make sure that that doesn't tip over, and as I said, I'm doing performance testing to make sure that we have built a system that works.
What happens when a machine is sick or unhappy? Do you try to fix it, or you just kill it, or how do you deal with that?
It certainly can't stay dead forever, so it does get fixed eventually.
And what's the first reaction when you find you have a machine with 2 bad drives? Do you kill the machine, or you try to hot replace the drives, or how do you deal with that?
That is a work in progress internally, but right now the machine gets killed.
Yeah, well, that's what we do too. Seems to make sense. Just shoot it, yeah. All right, cool. Thank you very much. Anything else you want to tell us about your hardware?
I think that.
All right, cool.
That's good.
Thank you. Thank you. And I'll spend a minute or two to talk about hardware, the current process at Salesforce. And I was actually not allowed to talk about the specific SKU we're using by our legal team, but I can say these things. So we used to have 30 different SKUs in our data centers, 30 different types of nodes we're running, and they were all special ordered and special racks and special parts of the data center with special networking. Everything was special. And then we did start the Single-SKU project, SSQ we call it, for almost all projects going forward, they have to use this one SKU. And 1U, we have the 10 gig E everywhere. You know, we might go to 100 gig E at some point. A fat networking tree with no or little oversubscription at any level, not at the Tor switches, not the spine. Well, there are no spines anymore. Not at the fabric. It's all full bandwidth almost from every machine to every machine. Mentioned that, you know, the same SKU used by all projects now with very few exceptions. We have one exception that sometimes get granted. It's a high storage SKU, and we have a high compute SKU, but they are really exceptions that we need to justify, and everything else has to use the single SKU. And we don't build our own hardware. We make our vendors build the hardware for us according to our specs. That has been working quite well. And because of the single SKU, we don't order by machine. We order sets of, say, 10,000, and we get them rolled in racks. And so this all matters, I think, obviously, if you run your own data centers. What that lets us do is, as I mentioned, we order or repurpose boxes in bulk, and then we assign them to projects. For each individual project, it's most likely a compromise, and people have bitched and moaned, including myself, about, I don't want to use this hardware. I can make much more use of the hardware if I add this and this and this. But this turned out to be much cheaper overall because of the bulk ordering, the rolling in the racks from the vendors, and because of the fat network, we don't even have to worry where the boxes are. We just order them, and as long as we have the failure zones right in terms of rack placement and so on, we just dole them out to the projects, including HBase. So then we could also not talk about the future if we don't talk about HBase 2.0, and so our own Matteo Betrozzi will talk about that. He's the release manager for HBase 2.0, so it's a really big task. Thank you for doing that.
Yeah. So I'm Matteo. I work at Cloudera. As Lars said in the beginning, HBase is not driven by a single company or a single entity. It's driven by the community, right? So who is driving 2.0? And again, it's the community, right? So what will be the roadmap for 2.0? The community decide the patches that will go into the next months will probably be in 2.0, right? But the idea behind 2.0 is to take HBase to a next level in terms of what we can change of the initial design, right? So we have a 1.x line where we basically said, okay, let's try to stick with binary compatibility, wire compatibility. And so we have this stable line that kind of works and can kind of go on forever, right? So why we should do a 2.0. And the motivation, it should be try to fix some of the design issues that are holding us back on a couple of items into the HBase product. So one thing that we need, though, is to avoid another singularity. So avoid another transition like we did for 94 to 96. So sure, we want to do a major upgrade, so with new feature, maybe breaking some API, but let's try to stick with something that users are familiar with. But we don't want to spend another upgrade with cluster downtime, right? So we don't want you to have another 94 to 96 migration where you have to shut down the cluster. There is no way to replicate and so on. So first of all, the main feature that I kind of I'm planning to cut the 2.0 branch on is the new assignment manager that the hope is that will allow us to do major rolling upgrade. So the cluster stays up, and the assignment manager will basically figure out how to migrate things if we need to change format or change coordination system. In the slide, there is a almost rolling upgradable, which seems strange, but the idea is that the cluster should be rolling upgradable, so you should be able to do data insert and data get, so you should be able to query your data or ingest your data without problems. The almost part is on administrator side of things, so it's like, can I take a snapshot while my cluster is in the middle of upgrade? And the answer there is maybe if it's not too much work to keep both the old version and the new version, we leave it in as feature as on during the upgrade. Otherwise, we may cut it out, so you lose some ability, but not the main read and write path. So yeah, new assignment manager is like one thing that will basically be the point where we decide to cut the branch, and then there are other features. And the other feature that are listed here are kind of the major feature that the community is working on or is planning to work on. Of course, there are tons of other little fixes that are going in, but in general, these are the main topic that the community discussed and is working on. The off-heaping work is something that is going on from a long time, and the idea is to get rid of the garbage collection problem, or at least try to avoid them. So we basically try to do our memory management and move the read path and write path of heaps, so to create less garbage. Another topic is replication, so some redoing of the internal replication. So moving out from Zookeeper, I think from the replication talk at Facebook, they mentioned that they're working on that. And it's like, try to get rid of Zookeeper as a storage, since it's not supposed to be a storage, and move the replication metadata into its own table. This will also allows us to do ACL on replication. So for admin operation like add peer, it will not require HBase user. Another thing would be the hybrid logical clock, which will help us in cases where you have clock skews or clock going backward, and we have data loss, those kind of problem. It also may help us in the future to simplify the write path and the sequence ID. But in general, it's like we will probably bring simplification, maybe open up to transaction and things like that. And the last topic listed here is backup. So we don't really have a backup story. We have snapshot, but they're not good enough. They don't do the backups as you expect from a traditional database. So there is work going on here. But in general, again, it's like all the patches that will go in the next months will basically be part of 2.0, right? So this is a roadmap with the items that the community is working on now or is planning to work on. But again, the roadmap is driven by the community. So if you have patches, if you have new feature, that will probably go into 2.0.
Thank you, Matteo. All right, running a little bit behind. So let me just close with that. What makes HBase truly special, right? What is the special place? And in order to talk about that a little bit, we've always made special machines, for special things, right? So this is, if you don't know what that is, this is a screw cutting machine. This is a rope making machine. This is a machine that shovels a lot of sand, from one place to another place. And this is a machine that makes Doom, right? So it's, so special machines, and so the HBase is a special data store for purpose, right? And so what's the purpose, right? And so the landscape is big. There's a jungle out there. There's like all these. So those are just the most popular names. There are literally hundreds or thousands of data stores out there, right? And so can you spot HBase there, right? Here, show it to you again. So where, right? So it's like it's on there, right? So I can help you a little bit. It's there, right? So, but how do you know when to use HBase, right? We get all these mixed signals from vendors to use that, or from other groups to use this, and it's not clear when to use HBase sometimes if you trust the vendors or the other projects, right? So let me try to define, and it's not easy, the HBase sweet spot, right? So what is that? First of all, we know HBase scales incredibly well, better than anything else I know. It will run at hundreds or thousand nodes. It will just work fine. As a key value store, specifically. There's the other stores like HDFS that scale like that as well. It's good for small scans, where small, 100 million rows scanned on the server, maybe, that still qualifies as small, and point gets, right? It's really good at that. Ops are kind of hard with HBase, but they are essentially a fixed cost. You will pay almost the same cost there for a 10-node cluster as you will pay for a 1,000-node. Not quite, but almost, right? So you still have to run all the master nodes, the name node, the zookeeper, QJMs, zookeeper failover controllers, all of this, you have to run those for 50 nodes or for 1,000 nodes. It's the same thing. But once you go over a certain size, these costs amortize themselves over the size of the cluster, which is quite nice. You need a consistent store, open source, on-prem or on cloud, obviously, and when you need a foundational, general-purpose, low-latency storage engine. And so now we'll make two controversial statements here. I will say there's no system that handles analytical and OLTP workload well. So in a single thing, right? So you may disagree, that's fine. Then you should, actually. And also, in this sweet spot that I just defined, there is no replacement that I know about for HBase. So if you have these kind of conditions there, HBase is a really good solution. And the last slide is, and you heard all of this already, so I'm just going to slam through it here. For modern hardware, we have to be able, you have to deal with lots of RAM, off-heaping, and memory compactions. We have to reduce the internal friction of HBase, and I spent a bunch of my own engineering time on this, to look at lock contention, memory fences, CPU stalls on the RAM, and there's a lot of work to do in HBase, especially when we move to SSDs and 10 gig like fast networks everywhere. HBase will become CPU bound, and that's a shame. Shame on us, and we have to fix it. Scaling, so you heard this morning from Francis, where he scaled HBase, the assignment manager, by splitting meta and ZK-less assignments to scale to actually 1 million regions. That has to make it into proper HBase. If it hasn't, I'm not sure now. Spark integration, we heard this from John and many other talks here. It's a very important thing so that we don't try to do analytics in HBase. It's not made for this. We could make it to do that, but we would have something that's not HBase. So let's not do it. Let's use Spark for that, which was made for that kind of workload. Also from Francis, earlier we heard that multi-tenancy is becoming more and more important. That is true for Yahoo, that's also true for Salesforce, and I assume for a bunch of other groups here. And easier interfacing into HBase. If you want to use HBase right now, you have to write some code. You have to write some Java, Python, any code to get data in and out of HBase. If you use sister projects such as Phoenix, you can use it just by running SQL queries and by upserting and selecting from HBase without writing any code. So we should make this easier. And then last not least, that's on my mind a lot, make the ops easier for HBase to make it like the default thing that engineers would go to. They now go to other stores that are actually not better when they start, but they're just easier to run in the beginning, right? And with that, time to party.